Okay, this is F, 5C, and D. I think it's C and D. Yes. 5C is a mean value theorem question, and 5D is an intermediate value theorem question. Part of the reason this question is kind of challenging is you kind of have to do guess and check. You have to actually do a guess and check. In this particular case, usually when you do mean value theorems and you do intermediate value theorems, the endpoints are good ones to use. What the question was the first question was, is there some time that we know that the acceleration has to be 2.5? And if you look at the endpoints here, remember, we have a theorem. What does the mean value theorem say? The derivative has to equal the slope. Now remember, the derivative of b, which is velocity, is the acceleration. And we know that's got to be 2.5. Or we're asking if it has to be 2.5, actually. That's the question mark. Well, now you could use any points, but you want to find one that actually has 2.5 precisely for an answer. So you want to use the endpoints here. You want to say b of 4 minus b of 0 over 4 minus 0. B of 4 is 11 minus 1 over 4. Now, again, you might go, this is kind of a coincidence. Yeah, I know it is. It's, it's on purpose. Sometimes you have to use, two other points when you do this question. But it is a guess and check question. But the main idea is that if that's velocity, all you have to do is find 2 points that when you take the change in velocity, like in this case from 1 to 11, and then divide it by the time that it took, you get precisely 2.5. So you kind of have to do some guess and check, but using the endpoints often will work if they ask you that question. So is there some time where the acceleration has to be 2.5? Yes. Why do we know that the acceleration has to be 2.5 somewhere? Because the average acceleration was 2.5, right? If the velocity was 11 seconds at the end of the interval and 1 meter per second in the beginning, that means it went up 10, the velocity went up 10, divided by the 4 seconds, that means that the average rate of change was 2.5. So, and again, what we know by what's called the mean value theorem is that the derivative has to equal the average rate of change. Now, you're going to use the same points in the next question, but now we're going to use something called the intermediate value theorem. So in the next question, and these are often next to each other on the test. It's not uncommon that they would put these two. So here's the idea. B of 0 is 1, which we know, and B of 4 is 11. Now, I found the same thing using the C function. C of 0 is 0, and C of 4 is negative 16. So look at what we know then. C of 0 is less than b of 0. So the velocity, because the velocity of c was 0, and the velocity of b is 1 when we started. So when the race started, and if you want to think of it that way, the velocity of c, and I think that's Chloe. Chloe's velocity was 0 when the race started, but I think B is Brandon. Brandon's velocity was 1. But at the end of the race, oh crap, that's not going to work. Oh, I thought I was golden and I'm not. Oh crap. Okay, I have to fix this question here. Okay, here's the thing. At the beginning of the race, Chloe's velocity is 0, and Brandon's velocity is 1. I gotta find another point in the race. I thought I could use 4, but no, they're both. Notice that Brandon is still going faster than Chloe. Oh crap. Okay, I apologize. I thought this was going to be easier. Okay, let's try 0. No, we can't use 0. Let's try 2. If I put 2 in here, what was, again, this isn't gonna work. Well, actually, this does work. The fours aren't gonna work, unfortunately. Let's try C of 2. At 2 seconds, 2 squared is 4. 4 minus 4 is 0. E to the 0 is 1, so I get 2. Okay, this will work. I found one. This is what you might have had to do in the other one. I kind of made a boo-boo there when I told you that the endpoint would work. And notice there's kind of a guess and check here. And B of 2 is 1.5. So here's what we know. We know that C of 2 is actually bigger than B of 2. Now make sure you get what happened. This is called the intermediate value theorem. We use a little bit of common sense. Intermediate value theorem is more like a common sense theorem, right? If Chloe was going at 0 at time 0 and Brandon was going at 1. So Brandon's velocity was bigger than Chloe's. But by the time we get to 2 seconds, Chloe's velocity is actually bigger than Brandon's. So here's the thing. If Chloe is going slower than Brandon at 0, but faster than Brandon at 2, what do we know? That sometime between 0 and 2, they must have been going the same speed, right? Right? Because if Chloe's going slower at time 0, but by the time we get to 2 seconds, Brandon's going slower. At some point between 0 and 2, they must have been going the same speed. So by intermediate value theorem, you have to have these two on your paper. You don't have to have the numbers necessarily. Well, the numbers aren't wrong. Chloe was going slower, then Chloe's going faster. You can't be going slower than someone and then faster than someone during a race without actually at some point during the race going this same speed. So by the intermediate value theorem, somewhere on the interval 0 to 2, somewhere between 0 and 2, the two people had to be going, C of t had to equal B of t somewhere between 0 and 2. We don't know exactly where, of course, but that's what has to happen.